Welcome, developers. Today, we are going to unlock the hidden control layer of Claude Code, system prompts. If you want Claude to act like a senior engineer tailored to your exact stack, rather than a generic assistant, you need to master the instructions that govern its behavior. Let's get started. Let's start with the foundation. What exactly is a system prompt? It is the foundational instruction set that sits invisibly at the top of the context window, defining Claude's identity, role, and boundaries before you ever submit a query. At a basic level, when you run Claude Code, it implicitly loads a system prompt that allows it to interact with your terminal. Why does this matter? Because without it, Claude is just a conversational chatbot. With a well-engineered system prompt, it becomes a senior developer that strictly follows your project's architecture. How do we control this? Through project files like claude.md or specific CLI flags. If we dive deeper, we see that the system prompt acts as the operating system for the agent, establishing the cognitive framework it uses to decide when to edit a file, run a bash command, or ask you for permission. Take a look at this flowchart representing the information hierarchy. At the top, the core system prompt flows into the context window alongside your user query and the local environment data. The Claude AI engine synthesizes all of this inputs. Because the system prompt was loaded first, it acts as the primary filter, dictating whether Claude decides to trigger a terminal action or simply return a text response to the user. Now, let's dissect the anatomy of an effective system prompt. What goes into it? We must structure it to establish a clear identity and a solid reasoning framework. The basics include defining Claude's role, its core behaviors, formatting rules, and tool constraints. Why do we need this structure? Because vague prompts lead to hallucinations, and overly rigid, step-by-step flowcharts will break the moment Claude encounters an unexpected edge case. How should you format it? Best practices dictate using XML tags to cleanly separate your rules from your context. In our deep dive, the golden rule is to empower, not constrain. Don't micromanage Claude's tool usage. Instead, provide heuristics. Instruct it to always review the surrounding code architecture before making an edit, and let Claude dynamically decide the best way to accomplish that. This diagram breaks down the 4 pillars of prompt anatomy. From the main node, we branch out to identity and scope, which defines who Claude is. Then, the reasoning framework, which tells Claude how to think. Next are tool constraints, ensuring safe execution. Finally, output formatting dictates how the response is delivered. The dotted lines provide concrete examples of what these instructions actually look like in practice. How do we apply system prompts to our daily workflow? Through Claude.md. What is it? It's a markdown file in your project root that Claude Code automatically injects into its system prompt at the start of every session. The basics are simple. It is your project's persistent memory. Why is this a game changer? Imagine never having to type, use Tailwind CSS, and functional React components ever again. The system knows it by default. How do you use it? Just create the file and list your build commands and coding standards clearly. For a deep dive, you must treat this file like production code. Keep it under 200 lines to avoid context bloat. If it gets too large, Claude will suffer from instruction blindness. If you have extensive rules, modularize them using import paths to load context progressively. Here we see the flow of persistent context. In your project root, you maintain the Claude.md file. This file contains your build commands, code style rules, and architecture notes. As soon as you launch the CLI, all 3 of these streams merge into the Claude context injection phase. The final result is highly consistent agent behavior across all your team members, without typing a single manual prompt. Sometimes you need to change Claude's behavior dynamically without altering your project files. This brings us to CLI flags. What are they? Command line arguments that let you override or append to the system prompt on the fly. The basics involve passing a string or a file path right when you execute Claude Code. Why would you do this? It is absolutely essential for CI/CD pipelines or when you want Claude to adopt a temporary, highly specialized persona like a ruthless security auditor. How do you do it? You use flags like system prompt to completely replace the default behavior or append system prompt file to add localized rules. Going deeper, if you are running Claude in a background automation script, combine your custom system prompt with the bear flag. This prevents local user settings from interfering, guaranteeing deterministic execution. Let's trace the sequence. The developer or CI pipeline executes the Claude command, passing the bear flag and a custom system prompt file. The CLI processes this by bypassing the standard Claude.md file, ensuring isolation. It then loads the custom review file as the absolute system prompt. This specialized payload is sent to the API, which returns a highly focused response back to the terminal, perfectly suited for automated scripts. A critical paradigm shift in system prompting is prioritizing heuristics over hard coding. What does this mean? It means providing guiding principles rather than rigid, exhaustive if/then rules. The basics involve teaching the model how to approach a problem, rather than detailing every exact step. Why is this vital? Because an AI agent operates in a dynamic codebase. If you hardcode a rigid flowchart, the agent will fail the moment a file is moved or an edge case appears. How do we fix this? Use heuristic commands. Tell Claude, always search for function references before modifying a file, or prefer composition over inheritance. In our deep dive, we leverage the fact that modern LLMs are pattern recognition engines. By giving Claude a generalized reasoning framework like analyze, plan, execute, verify, it will autonomously adapt to completely novel coding challenges successfully. This diagram illustrates the heuristic-driven agentic loop. A task input arrives and passes through the heuristic rules filter. Instead of blindly executing, the agent is trained to analyze context first. It then formulates a plan and executes via its tools. Crucially, the heuristics demand it verifies results. If verification fails, the system loops back to the analysis phase dynamically, adapting to the failure without human intervention. With great power comes great responsibility. Slide 6 is about safeguarding terminal and file access. What does this mean? It means embedding strict operational boundaries directly into your system prompt. The basics are simple. Claude Code has the ability to run live bash scripts and rewrite your files. You must dictate boundaries. Why? Because an autonomous agent trying to clean up your code might accidentally delete a vital database or rewrite your production config. How do you stop this? Write absolute constraints. Say, never run destructive commands without explicit user permission. For a deep dive, build verification hooks into the prompt psychology. Tell Claude, every time you use the edit tool, you are required to use the bash tool to run our test suite to prove you didn't break anything. This forces safety directly into the agent's workflow. Look at the safety flow shown here. When the Claude model decides to act, it immediately hits the guardrail check defined by your system prompt. If the action is prohibited, like a git push, it halts and asks the user. If permitted, it moves to tool execution. But we aren't done. The prompt forces a test suite verification. Only if tests pass is the change committed. If they fail, Claude loops back to fix the code. Let's apply this to a highly valuable real-time use case, the autonomous PR reviewer. The scenario: your engineering team wants Claude to automatically review pull requests in the CI/CD pipeline. The challenge here is strict scoping. Claude needs to understand the whole project, but it must act exclusively as an auditor. It cannot be allowed to alter code or run random scripts. The execution: we write a specialized reviewer-prompt.md file. In the CI pipeline, we run Claude in bare mode, overriding the default prompt with our reviewer file and passing the git diff. The outcome is spectacular. The system prompt forces Claude to act as a read-only auditor. It uses read and grep tools to check dependencies, validates against your project's architectural rules, and outputs a beautifully formatted critique entirely safely. This saves your senior engineers hours of manual review time. This sequence diagram maps the autonomous review pipeline. GitHub Actions triggers the Claude Code CLI, injecting our strict reviewer prompt. The CLI passes this to the Claude model, forcing it to adopt the strict auditor role. The AI analyzes the git diff using only read tools, checks the code against its heuristic rules, and generates a markdown critique. The CLI passes this back to GitHub, posting it directly as a PR comment. To conclude, let's lock in the best practices for system prompts. First, iterate on failures. If Claude makes a mistake, don't just fix the code in chat. Fix the root cause by updating your claude.md file so it never happens again. Second, prevent context rot. Regularly audit your system instructions and delete outdated rules to save tokens and keep the model laser-focused. Third, modularize. Don't stuff 500 lines of rules into one file. Use imported skills to load context dynamically only when needed. Finally, test systematically. Treat your system prompts like production code test changes against a baseline of tasks to ensure you are improving performance, not degrading it. If you want to dive deeper and master these agentic workflows, I invite you to like this video, subscribe to our channel, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for learning with us. Our final diagram shows the continuous improvement lifecycle. You write the system prompt and observe the agent behavior. When mistakes are made, and they will be, you loop down to refine heuristics and rules, updating the prompt, and testing again. Once you achieve 0 mistakes, you break out of the loop, scale the prompt to your team, and finally, take your next big step by visiting quicktechie.com.